Hey, have you ever run out of storage and wondered where all my space went? What if I told you that a large portion of it is wasted by duplicate files you don't even know existed? Hello everyone, I'm Tasin and I'm totally excited to present my project Smart Duplicate File Finder using multimodal cinematic analysis, a solution designed to effectively and efficiently detect and manage the duplicate files in your system using intelligent techniques. So, why Smart Duplicate File Finder? In today's digital world, we continuously create and download files from various locations. Over time, this leads to a numerous number of duplicate files getting stored across the system. Let me give an example. As a student studying in VIT, whenever I want to refer any material, I just go to the VTop page and download it, not knowing that I have previously done it. Right? So, due to this, a numerous number of duplicate files are sitting in my system. So, to solve this problem, I have designed Smart Duplicate File Finder using multimodal semantic analysis, which not only works on text but also images, videos. Now coming to how my project differs from already existing tools in the market. Mostly, the tools in the market uses hash-based technology which scans files based on the file name, file size, and small comparisons and allows user to delete the duplicates. But my Smart Duplicate File Finder not only identifies the duplicate files but also goes a step further by identifying the similarity between the two files. It also analyzes the content of the files and suggests the topics it belongs to. Isn't that cool? Which makes it easier for the users to understand and organize the data. Coming to how my project works. Firstly, it scans all input files and folders based on what you upload. Secondly, it analyzes the files based on simple attributes like file size, file name, and its content. Then advanced hashing techniques are used to ensure accurate duplicate file detection. Finally, duplicate files are grouped together for easier review. Makes the process fast, reliable, and efficient. Some of the features of my project include accurate detection, content-based comparison using hashing, user-friendly interface, option to preview and delete the duplicate files, and easier management. The dashboard and testing are shown here. This project can be included in personal computers, organizational storage systems, cloud storage management, data cleanup tasks. It is useful wherever large amount of data is stored. To conclude, Smart Duplicate File Finder is an efficient tool users can use to reclaim storage, improve performance, and organize their data in an efficient way. The hassle of manually finding the duplicates and provides a smart automated solution. Thank you.
Hello everyone, this is Loshika. So my topic is a multi-feature NLP pipeline for intelligent resume shortlisting and candidate ranking system. So here first you need to give the Conda active resume code, and then you need to activate the environment and run the Python code. So that's the first step which is happening over here. And then this is the localhost 80880, and you'll get the resume system which I've told you. This is the project, and once you log in, you need to enter your valid credentials so that it will enter into the system. And then here, this is the front page of my project, and here you're supposed to select the job description, and this is the respected code for the job description. So you can enter as many as job descriptions as required, so accordingly it will select the resume. So here I've entered Amazon, so accordingly it selected it, picked up 2 resumes matching to the job description, and it will also display the resume which has been uploaded by the candidate. So yeah, this is the job, this is a resume which was uploaded by the candidate. So there are like multiple resumes, and finally it will give scoring also to the resume. Thank you.
Hi, I'm Sampriti. Today, I'm going to present my project on text mining for sentiment analysis using Naive and Support Vector Machine. This project focuses on analyzing text data and identifying whether a sentiment is positive or negative. So, the problem statement. Nowadays, there are a huge number of online reviews, especially movie reviews and social media comments. It is not possible to manually analyze all of them. So, we need an automated system that can classify sentiments efficiently. So, the project objectives. This project follows a complete pipeline starting from pre-processing, feature extraction, model training, and finally evaluation and comparison. And this is the overall system architecture of the project. Dataset. For this project, I used the IMDb movie review dataset, which is a widely used benchmark dataset in sentiment analysis. It contains labeled reviews, positive and negative, which helps the model learn patterns in text. Now let's see the code. In this code, I have imported the libraries pandas, numpy and sklearn, etc. So I have loaded the data. Here I am loading the IMDb dataset. Then I convert the labels into numerical format like positive as 1 and negative as 0 in this line. In this line, I process the text data by removing stop words, punctuation, and unnecessary characters. And then I split the dataset into training and testing set to evaluate the model properly. And here I convert the text into numerical features using TF-IDF. I also use ngram, which means the model considers combination of words improving performance. Here I train two models, Naive Bayes and Support Vector Machine, to compare their performance. Then I evaluate both models using accuracy and other metrics. I also performed an ablation study to analyze how different techniques affect performance. Then, without processing, using counter vectorizer, using TF-IDF. This helps in understanding which approach works best. Here, I plot a graph comparing accuracy of both models. And this is the confusion matrix. This confusion matrix shows how well the model classifies positive and negative reviews. Here, I test the model using sample inputs. This model predicts whether the sentiment is positive or negative. So this this shows the model is working correctly. Now let's run the code. So here is the comparison graph between the Naive Bayes and SVM, and then here is the confusion matrix of SVM. So overall the project demonstrates how we can automatically analyze sentiments from text data. It can be used in real world applications like movie reviews, product feedback and social media analysis. This project not only builds a model but also analyzes different configurations to improve performance. Yeah, that's it. Thank you.